Solving equations, special cases. Recall that when we're solving an equation, we're looking for the values of x that make the equation true. So, exercise number 1. 5 minus 3x plus 4 equals to 1. First, we'll distribute the negative sign. So this turns into 5 minus 3x minus 4 equals to 1. We can then combine the 5 and the negative 4 on the left-hand side into a 1 minus 3x equals to 1. From here, we'll isolate x by subtracting 1 from both sides. On the left-hand side, that gives us negative 3x, and then on the right-hand side, we have 0. Divide both sides by negative 3. So on the left-hand side, we have x, and on the right-hand side, 0 divided by any number is 0. So what this means is if we plug in 0, we should get a true statement. So, simplifying, using order of operations, we have 5 minus, inside the parentheses, we'll multiply the 3 and the 0, which gives us 0 plus 4 equals to 1. Then inside the parentheses, 0 plus 4 is 4, so we have 5 minus 4 equals to 1. And then 5 minus 4 equals to 1. So notice that we plugged in 0 and we got a true statement. And so that's what it means to find a solution, right? Because this is true, x equals to 0 is a solution. Now if we were to plug in a different number, say 5 or 10 or 100, we would find a false statement. It would not be true. So x equals to 0, completely valid solution for this problem. So moving on to part B, we have 11 plus 3x minus 7 equals to 6x plus 5 minus 3x. Okay, first of all, combine like terms. So on the left-hand side, we have the 11 and the negative 7 will combine to 4 plus 3x equals 2. And then on the left-hand side, we have 6x and negative 3x as like terms. Those will combine to 3x plus 5. Now that we've simplified by combining like terms, the next step is to kill off the smaller x. But notice that both sides have 3x, the same exact value. So killing off the smaller x means subtracting 3x from both sides. This gives us 4 on the left-hand side, and it gives us 5 on the right-hand side. And notice the only thing we have left is there's no more variables, just 4 equals to 5. Now, if finding a solution is finding the value of x that make the equation true, but we have 4 equals to 5, 4 will never equal to 5, right? They're completely different numbers. And because this is never true, there are no solutions. Okay, so notice in part A, we have x equals to a number. And so whatever that number is, it's the only solution. In part B, because we have number equals to a different number, there are no solutions. And the key here is that it's a different number. Now for part C, we have 6 minus 2 times x plus 3 equals to negative 2x. Okay, so simplify by distributing the negative 2, which gives us 6 minus 2x minus 6 equals to negative 2x. First, we'll combine the like terms on the left-hand side. 6 minus 6 is 0, leaving us with negative 2x equals to negative 2x. Okay, from here, if I add 2x to both sides, we have 0 equals to 0. Now, at first you might say, hey, there's no more x's, so there's no solutions. But this time, we have 0 equals to 0, which is the same number. And in this case, 0 will always equal to 0, right? It's a number equals to the same number. And so when we have a number equals to the same number, this is always true. And so it doesn't matter what we plug in for x, it's going to be true. And so there's infinite solutions. So our summary is when we go through our work and we say x equals to a number, then it's going to be true just for that number. And so there's one solution, whatever that number is. When we have number equals to a different number, this will be never true. And so there's no solutions. And then when we have number equals to the same number, this will be always true. So there's infinite solutions.